Hey Florence, you look frustrated.
Yes, I am, because I'm taking an exam tomorrow about motion and its related topics, like speed, velocity, acceleration, etc. And you know my head is going to pop up, because I don't have any idea of it. Can you help me, please?
Yes, I can help you. Let's start.
Okay.
Motion. Motion is everywhere. Look to your surrounding and you will see it. Like car, moving along the road, people walking the street, and more.
But what is motion really is?
By the own definition, motion is a change of position of an object with respect with time and reference. But you cannot really understand it without looking to the things that describing it, like motion.
What are those things describing motions?
The things that describe motion are distance, displacement, speed, velocity, and time.
Can you explain those things to me?
Yes, I can. Let's start with distance and displacement. Distance is the length of the path of an object moved, while displacement of an object refers to the change of position. To be clear, let's have an example. An object moves from point A to point C, then back from point C to point B. The total distance covered by the object is 13 km. And in order to get the displacement, we can use the formula displacement equal final position minus initial position. Since our final position of the object is in 5 km, as you can see in the figure, and our initial position is 0. Then, 5 km minus 0 km is equal to 5 km. Then the displacement of the object is 5 km towarding east. However, not all the time object can move east or west. Sometimes it moves north or south. If that's the case, getting the displacement is not the same as we get the displacement in the previous example. Let's take a look. A car moves 10 km per hour to east and moves 5 km per hour to north. Get the displacement of the car. To solve the displacement of the car, we need to use vector addition. Now, the car moves 10 km per hour on east and then moves 5 km per hour on north. And based to the other definition of displacement, which say the shortest distance form initial to the final position. Therefore, we find it by using Pythagorean theorem, since it's form a right triangle, and the result is 11.18 km per hour, and to get the angle we can use trigonometric function. There we go, to the displacement of the car is 11.8 km per hour, 26 degrees northeast. Now you know what is distance and displacement. We can now proceed to the next topic, which is speed and velocity.
Does velocity and speed are the same?
No, there's not the same, because speed is the rate at which object move, while velocity is the rate of the displacement of the object. To be clear to you, let's have a comparison.
The 200-meter dash is a sprint that requires tremendous amounts of athleticism. In 2009, here in Berlin, Usain Bolt broke the world record for the 200-meter with a time of 19.19 seconds. How fast was he going? Well, that depends on how you look at it. How fast Usain Bolt was going depends on if you look at his average speed or his average velocity. Speed is given by the distance over time, whereas velocity is given by the displacement over time. We'll look at each of these separately. First, let's look at his average speed. When considering Usain's average speed, we consider the entire distance he ran around the track, which is a total of 200 meters. So we get that the average speed is 200 meters over 19.19 seconds. This gives us a total of 10.422 meters per second. Now let's look at velocity. When considering Usain's average velocity, we only consider the distance between his starting and ending position, which is about 115 meters. So we get that the average velocity is 115 meters over 19.19 seconds, which only gives 5.993 meters per second. No matter how you look at it, Usain Bolt's record is still an incredible feat.
Now, you have a clear idea about speed and velocity. We can now proceed to the next topic, which is acceleration.
What is acceleration?
Acceleration occurs when the velocity of the body changes over time. There are two types of acceleration.
Those are
Positive and negative acceleration. Positive acceleration occurs when the velocity is increasing, while negative acceleration occurs when the velocity is decreasing. And the formula for getting acceleration of the body is acceleration equal change in velocity over time. Now we know what are the things that describing motion. We can now proceed to the next topic, which is the three laws of motion.
By the way, who is Sir Isaac Newton?
Sir Isaac Newton is a scientist lived from 1642 to 1727. He developed the three laws of motion and published them in 1687, and three-volume work called the Principia Mathematica. They describe the relationship between a body and the forces acting upon it, and its motion in response to said forces. First law of motion. An object at rest will remain at rest unless acted on by an unbalanced force. An object in motion continues in motion with the same speed and with the same direction, unless acted upon by an unbalanced force. This law is called law of inertia. This means that there is a natural tendency of objects to keep on doing what they're doing. All objects resist changes in their state of motion. In the absence of an unbalanced force, an object in motion will maintain this state of motion.
Oh, that's the first law, so we can proceed to the second law?
Yes, the second law. The relationship of object mass m is acceleration a, and the applied force F, it means F equal ma. Acceleration and force are vector. In the direction of force vector is the same as the direction of acceleration vector.
An object will accelerate in the direction of the resultant force. The bigger the force, the greater the acceleration. By doubling the size of the force, it doubles the acceleration. Also, a force acting on a large mass will accelerate it less than the same force acting on a smaller mass. By doubling the mass of the object, it halves its acceleration. The relationship between these variables can be shown by the equation F equals m times a, where F is the resultant force in newtons, m is the mass in kilograms, and a is the acceleration of the object in meters per second squared. For example, if a car has a mass of 700 kilograms and the driver pushes the car with an acceleration of 0.05 meters per second squared, then the force applied was 35 newtons. You can also use the formula to work out the acceleration and the mass. And to leave you with a cool fact, a newton is approximately the weight of an apple.
Oh, that's the second law. What about the third law?
The third law. This law states that for every action, there is an equal and opposite reaction. To understand, let's have one illustration. As the ball hit the ground, it pushed the ground downward, and the ground pushed the ball upward. This is called action and reaction.
That's all the topic about motions and its related topics.
Yes, that's all.
Thank you, Naomi, for helping me. Because of you, I'm ready to take my exam tomorrow.
Welcome. By the way, I need to go. I hope you learn a lot from me. Okay.